today we're going to be looking at the last part of section 7b, the at least once rule. Now this formula actually looks a little bit more complicated than it is, but it's really just based on what we have already talked about, is that probabilities have to add up to be one whole. Either something happens or it doesn't. And when you have the at least once rule, you're looking at something that's happening at least once. Well, if it doesn't meet that criteria, then that means it doesn't happen at all. And like I said, the formula looks a little bit more complicated than it is. I think the best way to do these problems is to just sort of jump right in here. Problem 1, find the probability of getting at least 1 5 when you roll a die 4 times and write your answer as a decimal. Now, I like to start by coming over here and writing out the probability that I'm actually going to get this. The probability of getting a 5 when I roll a die is 1 out of 6. The probability that I will not get a 5 is 5 out of 6, because they have to add up to be 6 out of 6. My formula says I'm going to have 1 minus the probability that it's not going to happen, so 5/6, and I'm going to raise it to the power of n, where n is the number of trials. Well, in this case, my n is 4, because I'm doing this 4 times. So you raise that to the 4th power, and this is going to be approximately 0.5177. Okay. Problem 2, the probability of selecting a red M&M from a bag is 2 out of 5. If 5 M&Ms are selected, what is the probability of at least 1 being red? And write your answer as a decimal. Okay. The probability that is going to be red, I'm told in that first sentence, is 2 out of 5. So the probability that it is not red is going to be 3 out of 5. Don't look like an equal sign. And the probability that I'm going to get at least once red is 1 minus 3/5. Make this fraction down here, to the nth power. Well, how many times if I'm doing this? I'm doing this 5 times because I'm selecting 5 M&Ms. So that's to the 5th power. And you stick that into the calculator and you get approximately 0.9222. Problem 3, find the probability of getting at least 1 tail when you toss 4 coins. Write your answer as a fraction. Okay, so I'm going to come over here and write the probability of getting tails. It's 1 out of 2. The probability that you will not get tails is also 1 out of 2. So I have 1 minus 1/2 to the 4th power, because I'm doing this 4 times, so my n is 4. That is 15/16. Problem 4, 10% of the students have the flu. If you meet 8 students, what is the probability that at least 1 will have the flu? And write your answer as a decimal. Remember that when you see this at least 1 in your problem, you look at your reference sheet to find the at least once rule. The probability that somebody has the flu is 10%. I'm going to write that as a decimal. So 0.10. If you want to write it as 0.1, you can. The probability that they do not have the flu is 0.90, because remember these have to add up to be one whole. So I have 1 minus 0.90 to some power. Well, I've got 8 students that I'm meeting up with here, so I've got 8 as my n. And when I put this into the calculator, 0.5695. I find this to be interesting. You think, just 10% have the flu. That's a very small percentage. But then if you meet 8 students, chances are you're going to meet somebody with the flu. Problem number 5, find the probability of having at least one girl in a family of 5 children. All right, so the probability that you're going to have a girl is 1/2. The probability that your child will not be a girl is also 1/2. So we have 1 minus 1/2 to some power n. Well, n is 5. So that's to the 5th power. So that is going to be 31 out of 32.